Okay, pre-cal students, in this video, we will be looking at two different topics. We're going to be looking at imaginary numbers and complex numbers. Okay, now your heading today is complex numbers, and the lesson number is 2.4. Be sure and include today's date. Now, if you're wondering why we're looking at two topics, but yet your heading is only complex numbers, that's because we're mainly going to focus on complex numbers. You see, students, you can't have complex numbers unless you first understand what an imaginary number is. So that's why we're looking at two topics, imaginary numbers and complex numbers. But most of our focus today will be on complex numbers. Okay? Alright, let's continue on. Now, let's start off first, like I just said we are going to do, looking at imaginary numbers. You need to know what an imaginary number is before we can talk about complex numbers. So, here we go. First, remember, students, you can never take the square root of a negative number. Now, we know the square root of 4 equals 2. However, if I asked you to find the square root of negative 4, the answer would not be negative 2. Okay? Because negative 2 times negative 2 equals positive 4, not negative 4. There's no two numbers that you can multiply together that are identical numbers that will give you negative 4. And so you cannot take the square root of a negative number. Okay? Please don't forget that. Because of this, mathematicians use the letter I to represent the square root of negative 1. Okay? So you might want to write that down. The main thing is that you want to see is this, or the main thing I want to show you is this. If you have the square root of negative 16, you can rewrite that like this. The square root of 16 times negative 1, correct? Sure you can. And then we know the square root of 16. Cross it off, put a 4 on the outside, and you're left with 4 square root of negative 1. Now, what does the square root of 1 stand? What is the square root of 1 represented by I? So then you would put I for this right here. So you would get 4I, okay? So there's a faster way to do what I just showed you, and we're gonna go over this later. But the fastest way is just this. From now on, anytime you have a square root, and students, it must be a square root, not a fourth root, not a sixth root, not a cubed root. Anytime you have a square root of a negative number, you can make it positive as long as you put an I on the outside, and then take the square root of 16, and you would get 4I. Bring the I down. Okay, but we'll talk about that later. The main thing I want to show you is that the letter I is used to represent the square root of negative 1. Okay, you need to know that. I represents the square root of negative 1. Now, don't forget that if I equals the square root of negative 1, then I squared equals negative 1. And you're probably thinking, well, where'd that come from? Well, let me show you. I equals the square root of negative 1. That's what I told you right up here. Okay? Now, let's square both sides. Let's square this side, and let's square this side. If you square I, you get I squared. And if you square a square root, you get the number on the inside, which is negative 1. So that's where we get this right here. Okay? You must know this. You need to know this. Or this, same thing. These two things here with arrows are the same thing. You need to know that. And you need to know that I squared equals negative 1. You need to know that. Alright, so with all of that in mind, let's simplify some square roots quickly using this information. Then we'll get to the main part of the lesson today. Okay, here we go. I want you to simplify the square root of 7. Okay, well, I just taught you how to do that a little bit ago. Anytime you have the square root of a negative number, you make it positive and put an I on the outside. Okay, so your answer would be square root of 7I. Now, if you can break down the square root of 7, then go ahead and do so. But you can't, so this is good enough. Alright, let's take a look at the square root of 16. If I'm going too fast, just pause the video. First of all, make the 16 positive. represents the square root of -1, and we call numbers with the letter I, we call them imaginary numbers. Okay? So, this is an imaginary number. This is an imaginary number. Alright? Now be very careful here with this one. First of all, we have a square root of a negative number. So make it positive and put an I on the outside. Got it? Well, the negative just stays here. There's nothing you can do with this negative. So your final answer is negative square root of 13I. Okay? Alright. Now, let's continue on. What about this, students? What about when you're multiplying? What about when you're multiplying two radicals like this? Now, if you remember in Algebra 1 and Algebra 2, you've been taught your whole life to multiply the outside numbers, 6. Multiply the inside numbers, -3 times -4 is 12. And then simplify. The problem with that is it's kind of like an order of operations problem. The problem is you always want to get rid of negative radicands first. Now, radicand is the number under the radical. Just so you know that. It's called the radicand. Okay? And this number here, square root, cube root, fourth root, whatever, that number there is always called the index. Okay? So the problem is, whenever you have a negative radicand and a square root, you're expected to first get rid of the negative sign. Okay, that's very important. You don't multiply the two negatives first, okay? And you're going to see we're going to get a different answer. So you first must eliminate negative signs. So make the 3 positive and put an I right here. Times, make the 4 positive and put an I right here, okay? Now multiply these two groups together. 2 times 3 is 6. 3 times 4 is 12. I times I is I squared. Okay, look that over. Make sure you don't have any questions. Alright. Now, we're almost done, but the 12 can be broken down into 4 times 3. And by the way, I expect you to do that to radicals. Okay? So learn how to do that. Why would you not put 6 times 2? Because you cannot take the square root of 6, and you cannot take the square root of 2. If you're going to break a number up into 2 factors, make sure you know the square root of at least one of them. So 12 is 4 times 3. Cross off the 4. The square root of 4 is 2. Put a 2 on the outside. You multiply them. So now we have 12 square root of 3. Now hold it. I squared. We talked about this way back here. I squared equals what? -1. So where the I squared is, we're going to put -1. Okay? So we have 12 times the square root of 3 times -1. So your final answer is -12 square root of 3. Please make sure you can do these types of problems, okay? That's really, really important to be able to simplify these accurately. Okay, now let's take a look at simplifying complex numbers, okay? First of all, before we do that, let's quickly review or learn what a complex number is. I say review because really most of this stuff, if not all this stuff that we've had so far in Chapter 2, should have been covered in Algebra 2. We're just covering it faster and in bigger quantities and doing some more difficult problems than you would do in Algebra 2, but a lot of this should look familiar, okay? So let's review or learn what a complex number is. Here's an example of a complex number. Whenever you take a real number and put it with an imaginary number, you get a complex number, okay? So make note of that in your notes. What if you take a real number and an imaginary number and put them together? You have what we call a complex number. Now, this is called standard form right here if you want to make note of this. A complex number is in standard form when it's written in A plus BI form. In other words, parts. A is your real number. Your real number comes first. BI is your imaginary number. It comes second. Okay? So that's what a complex number is. Wanted to quickly review that. Now, we're going to do a lot of simplifying. Look at these problems and make sure that you see the difference between each one. And then we're going to simplify them, okay? Here they are. Because every one is done differently. So you should be able to see the difference. Here we're adding two complex numbers. Here we're subtracting two complex numbers. Here your two complex numbers are side by side. Here you're dividing complex numbers, and here you're adding two fractions, and after you add them, you're going to divide them out. Alright, so here's what I'm going to do. I'm going to continue on, and I'm going to start working these problems out. If I were you, I would have the supervising teacher pause the video. Everybody copy all these down so that they're in your notes, and then we're going to be able to work them out quickly, okay? But I'm going to go ahead and get started on this one. So if you guys want to copy these down, pause the video, do so, and then restart the video. Alright, here we go. Students, first of all, let's start off with this problem right here. Now this problem here, notice we have a positive sign in front of this parentheses, even though you can't see it, and a positive sign here. So we take the positive sign and we multiply it through. Positive times a positive is positive. Positive times a positive is positive. When you take a positive sign or a negative sign or a number and multiply it through the parentheses, it eliminates the parentheses. So now the parentheses are gone. Now take this positive sign and multiply it through. Positive times 3, positive times 7i. And now you can simply add your like terms. 8 plus 3 is 11. 6i plus 7i is 13i. Isn't that amazingly simple? It really is. It's written in standard form, and you've added two complex numbers together. Alright, let's take a look at another problem. Now, here we're subtracting two complex numbers. Notice there's a positive sign here, even though you can't see it. So take your positive sign, multiply it through. Positive times a positive, and positive times a positive. Now, take your negative sign and multiply it through. Negative times a positive. Negative times a negative. And now combine your like terms. 4 and negative 6. Negative 2. 5i plus 3i. 8i. And there we go. Okay. So pretty simple. We subtracted two complex numbers. Alright. Let's take a look at the next problem. We're going to multiply two complex numbers. Now you're going to do this just like you were multiplying a binomial, like 2x minus 5 times x plus 3. Take the 2x and multiply it through. Take the negative 5 and multiply it through. The exact same thing, okay? So here we go. Let's go ahead and multiply these two complex numbers together. Take the 1 and multiply it through, okay? 1 times 1 is 1. 1 times 3 is 3i. Now take the positive 2i and multiply it through. 2i times 1 is positive 2i. 2i times 3i is positive 6i squared. Okay? Alright. Now, we're looking for common terms, but before we do that, notice I have an I squared here. Do you see that? So really, to be honest with you, I can get rid of that I squared and put a negative 1 there. Because remember, I squared equals negative 1. So now that changes everything. Now I have 1 plus 5i, 3i plus 2i. And then positive 6 times negative 1, negative 6. Now combine these two numbers here, and you get negative 5 plus 5i. Notice how I write all of my complex numbers in standard form. A plus bi. Okay? Very important. Okay, we've done pretty much the three easiest problems so far, so now we're going to move on to some tougher problems. Alright, so let's really take some good notes here. Now, first of all, I want to point out to you that we're dividing two imaginary numbers. Now, the way to do this is to use something called the conjugate. Okay, if you want to make note of that. Conjugate. And the conjugate of an imaginary plus 6i. The conjugate would be 1 minus 6, or 1 plus 6i. Notice I did not change the sign of the first term. I changed the sign of the second term. Okay? So the conjugate of 2 minus 5i would be 2 plus 5i. Do you understand that okay? If I had an imaginary number like, I don't know, 2 plus 6i, the conjugate of this would be 2 minus 6i. It's a very simple concept. We're going to use the conjugate. We're going to use the conjugate to simplify or to divide these two complex numbers. What you always do is you take the conjugate of the denominator and you multiply it times the top and the bottom. Well, the conjugate of the denominator is 1 plus 6i. Now you're allowed to multiply. You're allowed to multiply this fraction right here by anything you want, as long as you do it to the top and the bottom, and we are totally doing that. We're multiplying the top and the bottom by the same thing, okay? So here we go. Let's see what happens here. Let's take our time and really, hopefully I won't make any mistakes on this. Okay, top times top. 2 times 1 is 2. 2 times 6i is 12i. Now take your negative 5i and distribute it through. Negative 5i times 1, negative 5i. And then negative times a positive is negative. 5 times 6 is 30. And then I squared. Alright? Now, you guys are smart students. I can do this quickly. Where the I squared is, I'd have a negative 1. So negative 30 times negative 1 would really give me a positive 30. So you have negative 30 times, put a negative 1 right here, and you get a positive 30, okay? So I'm going to go ahead and put a positive 30 here, alright? Now, for the denominator, we have 1 times 1 is 1. 1 times 6i is 6i. Now, negative 6i times 1 is negative 6i. Negative times a positive is negative. 6 times 6 is 36. And then I squared. Well, we know I squared is the same thing as putting a negative 1 here. Okay? And negative 36 times negative 1 is going to give you a positive 36. Alright? Now, the reason we use the conjugate whenever you multiply a complex number times its conjugate, the middle terms cancel out. So I'm simply left with 1 plus 36, which is 37. Now your numerator is 2 plus 30, 32. And then 12 minus 5 is 7i. Now you're not done until you've written this in standard form. So standard form would be 32 over 37. Then take your sign here, plus 7 over 37. Then put the I right here. See how we did that? We made a fraction with these two numbers. Then we made a fraction with these two numbers. And then we put the plus sign. This sign here goes right in the middle. And this I goes right here. And there we go. So we took this original problem right here and simplified it down to this right here. Okay? Alright, so look that over, see if you have any questions, and now we're going to go on to probably the most difficult problem we're going to look at, okay? And then we'll be finished with the video. Here it is. Now, students, the first thing I want to point out to you is if we're going to put these two together, we have to have a common denominator, okay? And guess what? We do have a common denominator, okay? So we're looking at this being pretty easy. Now don't forget, if I had 1/2 plus 3/2, my answer would not be 4 over 4. When you're adding fractions, you do not add your common denominator, you know that. So it'd be 4 over 2. Well, it's the same thing with complex numbers. You don't add the denominator. We have a common denominator, so we bring the common denominator over. And then we add the top, so 3 plus 6 is 9. 2i plus 2i is 4i. Okay? There we go. Now, we have the exact same problem we just had a second ago, okay? And when I said that we were saving the most difficult problem for last, I didn't know we had a common denominator. I thought we had to get a common denominator, so this is really pretty simple. We're going to multiply the top and the bottom by the conjugate. 1 plus I. 1 plus I, okay? So here we go very quickly. 9 times 1 is 9. 9 times I is 9i. Now we'll take the 4i and multiply it through. 4i times 1 is 4i. is this a negative 1? And 4 times a negative 1 would be a negative 4. So we're going to make that a negative 4. Now let's look at the denominator. We have 1 times 1 is 1. 1 times I is I. Negative I times 1, negative I. And then negative I times positive I is negative I squared. Now don't forget what I squared is. We can put a negative 1 right there. So we have negative, negative 1, which really gives us a positive 1. Alright, now let's simplify. In the numerator, we'll have 5, 9 minus 4, and then plus 13i. Got it? Now the denominator, these cancel like they're supposed to. 1 plus 1 is 2. So let's write this in standard form. 5 over 2. And take your sign from here. Plus, and then 13 over 2. And then I right here. Okay? So the math today is really